Humans who witnessed the invention of steam power, mass production of steel, and electricity couldn't have predicted the massive impact these innovations would have on our civilization. Only with hindsight can we point out moments in history that changed human civilization forever. Scientists believe that we may be at one of those turning points again. Only time will tell how true these assumptions are, but for now, keep watching to find out what they have to say. First up, the next industrial revolution is happening in space. A new industrial revolution is taking place in low Earth orbit, just 250 miles over our heads, and we believe it might be the most profound chapter in human history. You see, our civilization is at a crossroads, transitioning from 60 years of space exploration to a new era of unprecedented economic activity, manufacturing, and growth in space. For a long time, the question has been, where are we exactly transitioning to? Well, it seems like it's space. Some of the greatest minds on the planet believe that the orbital age is a rapidly growing epoch that will fuel a new trillion-dollar industry in the near future. Next up, what exactly do we aim to gain here? The ability to manufacture hardware in space is expected to revolutionize a wide range of space activities. The prospect of in-space manufacturing has benefited greatly from rapid advances in manufacturing and assembly technologies, as well as recent developments in on-orbit servicing and active debris removal. We still have to see if this is actually possible. Several manufacturing processes have been tested in a simulated space environment, and in-orbit tests are planned for the coming years. But if this actually happens, the possibilities are endless. As the businesses and factories of the orbital age establish a permanent human presence in low Earth orbit, we think we are on the verge of the full-scale commercialization of space. The widespread belief is that things like microgravity, increased radiation levels, and a near-vacuum state create an extraordinary environment that will allow for discoveries to improve life on Earth. This means that biotech firms, pharmaceutical companies, semiconductor industries, and other advanced material manufacturers will be able to innovate and manufacture their next breakthrough products on Earth in space microgravity factories. Orbital manufacturing will also unlock billions of dollars in value for businesses, especially pharmaceutical companies. According to a recent study from McKinsey & Company, pharma companies could make up to $4 billion in annual revenue by collaborating with space companies. Now, a lot of this is riding on the back of microgravity, but does it even work? You'll be glad to hear microgravity manufacturing is tried and tested. Back in the 90s, materials scientist Alex Ignatieff invented a semiconductor while on board a NASA platform in low Earth orbit called Wake Shield Facility. This semiconductor was 10,000 times better in quality than the ones produced on Earth. Then, during a weightless parabolic flight in 2016, bioengineers used a 3D printer to create a two-chambered structure of an infant's heart from stem cells. So yeah, we'll say this is a pretty safe bet. Moving on, think of this as the invention of the internet. The internet has come an incredibly long way in the last 25 years. Some of you might still remember when fast food chains used to put a simple form on a basic website and call it e-commerce 1.0. And if you wanted to order a pizza online, you'd enter your phone number into that form and wait a few minutes for a call on your landline. Now, you can have almost anything delivered to your door with just the click of a button. However, none of this happened overnight. The consumer internet that we have today is the result of years of innovation in computer hardware, data storage, cloud computing, and other areas. We believe that a similar evolution will take place on the LEO. Citibank recently predicted that the global space sector will generate $1 trillion in sales by 2040, suggesting space has an internet-level economic opportunity. And you know what that means? Equity investors are taking notice. According to reports, there were over $14.5 billion in investments in space ventures in 2021 alone. Now, why did it take so long? More than 50 years have passed since Neil Armstrong joined Buzz Aldrin and Michael Collins landing on the moon. However, the inspiring high of Apollo 11 was followed by a steady decline in interest in space. For the past half-century, innovation in space tech has been pretty stagnant, apart from a few advancements. But finally, we are at the cusp of another space race, which has triggered unprecedented innovation, as well as a massive effort toward American reindustrialization. Then there's also the economics of the thing. You see, the invention of reusable rockets and cheaper fuels is lowering launch costs and increasing the frequency of trips to low Earth orbit, and this has made it way easier to fund space exploration. Coming up, let's talk about recent developments. NASA has shifted its focus away from owning the space platform and more toward funding research and development and mission grants for private companies, such as Elon Musk's SpaceX and Jeff Bezos' Blue Origin. China and Russia are also cramming satellites into low Earth orbit, and on at least one occasion, blowing one up, resulting in dangerous space debris. China and Russia are racing the United States and friendly partners to establish a permanent base on our mineral-rich moon in order to maintain their strong positions in raw materials and manufacturing. While on the civil aviation side of things, private companies are driving unprecedented innovations in the field, such as electric flight, supersonic commercial flight, and even flying taxis. In short, we live in an era where significant geopolitical and economic forces are driving the space race to innovate like never before. Next up, IBM and Sierra Space sign an MOU. The MOU outlines the company's plans to integrate IBM technology to coordinate the tasks and workload of Sierra Space astronauts using the company's data analysis and collection technology. Furthermore, IBM intends to assist Sierra Space in its journey to develop a seamless technology platform in space, which both envision as a first-of-its-kind, comprehensive platform to effectively service the cloud in space and drive mission operations, all while supporting the development of new applications for commerce, research, tourism, and other purposes. Moving on, let's talk about the Space Cloud. According to IBM and Sierra SPA, in order to service a growing economy in low Earth orbit, we will absolutely need a dedicated space cloud for sharing and storing data. Ken Shields, Senior Director of Business Development at Sierra Space, which is one of the companies developing the Orbital Reef Commercial Space Station, believes that ushering in the orbital age will necessitate robust space compute and data capability. Sierra Space plans to launch a test station into orbit within the next 3 years to show that its technology works and can be used to keep humans in space for long periods. But first, they must figure out how to manage data. And that's exactly where this new partnership with IBM comes into play. The two tech giants will collaborate to develop a new generation of space technology and software. Whatever comes out of this partnership will be used by Sierra Space's fleet of space vehicles and infrastructure, including the Dream Chaser spaceplane, which is scheduled to launch for the first time next year with cargo for the International Space Station. This partnership will see IBM integrate its technology to coordinate astronaut missions, connect devices in orbit, and help with the transfer of data from research projects back to Earth. Moving on, Shields explains why it's difficult to move data around in space. It's challenging when you're trying to move data around, Shields says. He then added that the ISS does a decent job at data storage, but that it's pretty limited. You see, right now, they can save and secure the data, but they can't move it around. Now, with the help of IBM's technology, Sierra Space will be able to improve in-orbit processing, as well as increase automation. They will develop a unified and flexible distributed computing environment for the orbital ecosystem that can be expanded over time. This environment will allow users to easily build and modernize applications, making data AI ready, and integrate and orchestrate workloads. According to IBM, this project will include the use of AI and edge computing, as well as provide access to multiple vendors. Finally, this will be a platform that will help humanity grow. While speaking to Tech Monitor, Shields stated that Sierra's mission is to build platforms that will allow humanity to grow and expand everything we do on Earth into space. This means turning space into a place where we can work, live, and even establish industries. But for that to be made possible, we need to put some solid infrastructure down first. And the Space Cloud is going to play a major part in that. Now, it's no secret how important storing and analyzing data is, especially since we're still in the early stages of space exploration and colonization. This is why Sierra and IBM are trying to make data analysis in space as easy as possible with their cloud system. Here's to hoping everything works out. That's a wrap for this video. Do you think the next industrial revolution will take place in space? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. See you in the next one.